Welcome to Learn Elite Academy. Good day, fellow listeners. Today, I want to make a short video on the pinhole camera. Now, when we talk about the pinhole camera is an opaque box used in the 11th century for viewing eclipse of the sun without dangers to the eyesight. That is the pinhole camera. It was used in the time past, in the 11th centuries, for viewing what? Eclipse of the sun without a damage or danger to the eyesight. That is the pinhole camera. But this pinhole camera, it works on the principle of rectilinear propagation of light. The phenomenon whereby light travels in a straight line. That is the principle which the pinhole camera works on. Now listen. The image formed by this pinhole camera, they are always what? Inverted. They are magnified. And they are real images. And we know what real image is. When we say a real image they are images that can be caught on a screen. The opposite of a real image is a visual image, the one that cannot be caught on the screen, a negative image. But here we are talking about what? Real image, produced by the pinhole camera. Like I said the image formed by the pinhole camera is always real, magnified, and inverted. You must know these three. Now, one thing I want to show you, the pinhole camera is a wooden box. It's something like this. Let me show you like this. It's something like this. The pinhole camera. We have it like this. If this stand as the object, now this is the screen. Okay, we take here now as the screen. Take here as the screen. This is the hole. This is the hole. And now this is the object. Now you see here now, here stands as what? The image. Look at the image. This is where the image. This is the screen. You see? And from here to here, look at me, from here to here, we call it what? Object distance. While from here to here, we call it image distance. You see now? Now, object distance, I can denote it as this. I can take it as this. Image distance, I can take it as this. Now, like as I said from here to here, we call it this is the object. This is the pinhole. Look at the hole. This is the hole we are talking about. Now, from here now, we can trace it like this to this point. You see? Now we trace here like this to the pinhole, the same thing to this point. So this is the pinhole what? Camera. From here now, if you look at it, from here to here like this. Now, from here now to here, from here now, this is the image. You can see the image, the object here. This is the object, this is the image. Why from here like this to here? We call it what? From here like we call it image height. Image height. Denote it as object height, not image height. Object height. H subscript O. Why from here to here? We call it image height. Image height. Denote it as HR. Take note of this. We are talking about the what? The pinhole camera. But one thing I want you to know about the pinhole camera is that a small hole produced when the hole here, this hole now, is small. a small pinhole camera, a small pinhole, take note of that, produces a sharp image. Produce a what? A sharp image, but less bright. That is, if the hole is small, is tiny, then the image will be what? Sharp. But at that time, the image will be less bright. That is, I'm talking about the hole now. But now, if the hole in the pinhole camera, as you can see now, this is the hole now, so I'm talking now. If the hole now, as I'm talking about now, is not enlarged, if the hole is enlarged, the image will not be blurred, but what? But will not be what? Brighter. At that time, when the hole is now enlarged, when you enlarge this hole now, the image here now will be blurred, and it will be what? It will be bright. But if the hole becomes small, like than this, it's reduced, the image becomes sharp but less bright. But if the hole is big, I said the image becomes what? Blurred, but become more brighter. Are you getting now? And that time, this image you are seeing here now, the image now, the blurred image is due to diffraction of light around the hole. This blurred image I'm talking about now, when this thing is increased now, the blurred image produced now is as a result, is due to what? Diffraction of light around the what? The hole. That's what we're trying to say now. Now, this is the object. When you brought this object closer to the pinhole, listen carefully. When you brought this object closer to the pinhole, the image here, the size of the image will what? Increase. Take note. But if this object is not taken further away from it, then the height here becomes smaller. It becomes diminished. You get it now? So you must know one thing about the pinhole camera. Like as I've said, the effect produced by reducing the hole, it make what? That time the image become more sharper. It produces a what? A sharper image when the hole is small. But when as the hole is not large, when the hole is large, the image become what? Blurred. Now, take note of this. But here now, I want us to look at something else. Listen. I want us to look at something else now. Let's look at how the magnification produced here. In magnification. Now, when we are talking about the linear magnification here, the linear magnification generally, I want you to understand that linear magnification is simply the ratio of the image distance to the object distance, or image height, the ratio of the image height to the object what? Height. That is when we are talking about what? The linear magnification. How do we write it? This is how we say the linear magnification. Linear magnification. In this case, M becomes image distance over object distance equals to image height over object height. You see now, which can also, I can write it like this. Image distance, I can write it like this. Object distance, I can write it like this. Image height, I can write it like this. Object height, I can write it like this. So when we are saying the magnification, it's just something like this. But now I want to show you something now. Take for instance, I want to make you know that this magnification you are seeing here is equal to what? The tangent. Is equal to what? Tangent of an angle. Look at me. I want to put something to you. Now, if we trace this line, look at me from here. If you look at this line very well, this straight line. Look at me. If I take it and draw it like this, I now take this as the word, the center. I can take this up. I can take this down. At the end of the day, I can decide to join this to this. I can join this like this. Now, at the end of the day, when I join it, I can make this angle to be theta. This angle is also theta, vertical opposite angle. You see now, if these two, this theta, this theta. Now, what happened? Remember, we said that this is the object. This is the height of the object. This is object height. We said so. This is what we said. This is the object, and we said that this is the image. And this is the image here. You see the image. This is the image word height. While from here to here, we take it as object distance. From here to here, we take it as what? Image distance. We take it like this. Now, according to tangent of an angle, I can see that tan theta here now. Tan theta is opposite, which is this, over what? This. Equals to what? We have what? Tan theta here is this over this. Now, we have said that tan theta become equal to this. But according to ratio, according to rule of ratio, when you have a ratio given to you, look at it, we have a ratio A upon B equals to C upon D. Likewise, we can also write this ratio. When we invert the ratio now, in other words, I can say that D over what? B equals to C over A by alternating these two now. You see now? Look at it now. A here. You see now? This is what we did now. So likewise, I can say therefore, this now, tan theta cannot be what? If I decide now to alternate this and this, I can stand and say that here becomes this over this equals to what? This upon this, which is the word magnification produced. So I want you to get this very clearly. It's an important thing. You know what mean when they say magnification. The magnification, I have defined it before. I said that is the ratio of the word image distance to object distance, or the ratio of image height to object height. That is what we call the linear word magnification. Now here we have some example on Pinhole Camera, example 1, 2, and 3. Now, if you look very well, I want to look at this example 1. Let's look at it. He said a man 1.5 meter tall. Now, let's take solution. This is a man. Let's assume this is a man. This is the height of the man. From here, 1.5 meter tall. This is a man. It's 1.5 meter tall from a pinhole camera. Tall. In this standing 3 meter in front of a pinhole camera. That is, from here now, this is the height of the man. This is the man now. The height of the man is 1.5. It's 3 meter from the pinhole camera. Remember this 1.5 meter pinhole camera. This is the pinhole. Look at it. Look at it here. We have it here like this. The pinhole camera, we have it like this now. The man is standing camera whose distance between the hole and the screen is 0.1, meaning from here to here is 0.1 meter. That's what they're saying. Say what is the height of the image of the man on the screen? That is to say, if the man is here, if this is the screen, this is the man, this is the man. They are asking for the height, image height. That's what we are looking for. Look at it. So here we all know that magnification is what? Is image distance over object distance, which equals to image height over object what? Height. So therefore, our image distance is 0.1. Look at it here. Divide. Object distance. Our object distance is 3. Look at it. Image height, look at it, is what we are looking for. Image height. Object what? Height is 1.5. 1.5 in this matter. So now, what happened is this. We now what? To make this the sorry formula, we have to use this to multiply both sides. We multiply both sides by what? 1.5. So if I come here now, I can say yes times 1.5. I can say here 1.5 times this. Are you there? So in other words, this can cancel this. If this cancel, what happens? We now have this, which is what? 1.5 times 0.1 upon what? 3. Go. Now, from here now, this times it becomes 0.15 upon what? 3. So in other words, when you divide, therefore, this become what? 0.05 what? Meter. This become what? The image height. And the question, the image height. That become the image height. Now let's look at this other question here. Number 2 here. The same number 2 now says, it said an object. Good. So now, in this case now, like we have solved it, we have found out that our answer is what? 0.505 meter. But in this other question, an object of height, this, meaning this is, we are using the same diagram now, this is what? 4 centimeter. That is the height. Is placed in front of a cuboid pinhole camera. Listen to me. When we say cuboid, you should know what cuboid is. Let me draw the diagram. Let me draw it. This cannot go. Let's look at it this way. When we are talking about cuboid, we are talking about something like this. We are talking about something like this. Cuboid pinhole camera. We look at it this way. Now, this is the hole, and this is screen. This is screen. Now, we trace from here now, look at it. This is what? The body, the object. Now, you see now, the question is that an object of height 4 centimeter, meaning here 4 centimeter, from here to here like this, is 4 centimeter. You see now, is placed in front of a cuboid pinhole camera of size 6 centimeter. The size, are you getting now? Pinhole camera of size 6 centimeter. From here to here now, which is from here to here, is 6 what? Centimeter. Now listen, if the image form is 2 centimeter, the image from here to here like this is 2 what? Centimeter. The question, hi, how far is the object from the pinhole? What they ask us to calculate is just this, from here to here. They say, what is the object distance? That's the question. So in a case like this, all we just need to do, we already know that magnification is this by this equals to this over what? This. This is what we are saying. So in a case, in this format like this, when we say the magnification, listen carefully. We are talking about what? Magnification equals to this now. So what is now our image distance? Is 6. 6. Object distance is unknown. Look at it here. This is the object distance. Now here we have image height 2. Object height 4. So in this case now, we are going to what? Divide both sides by 6. Although, let's look at it this way. Listen. From here now, if we cross multiply, we are going to say 6 times 4 equals to this times 2. Divide both sides by 2. We now say that this become 6 times 4 divided by 2. And if these two cancel, the years 2. So our answer becomes 12 what? Centimeter. So our answer then becomes 12 what? Centimeter. And that is the correct option will become what? 12 centimeter. Now, this is example 3 now. A pinhole camera is placed 300 meters in front of a building. Now, let's take this is the building. Take this as a building. Take this as a building. If we take this as a building, it's placed in front of a pinhole. This is Now, there's a building in front of it. If you look at it now, the question is that a pinhole camera is placed 300 meters in front of a building, meaning from here to here is 300 meters. So that the image is formed on a screen 5 meters from the pinhole. Now, if we say the image, look at where the image is 5 meters from the pinhole. This is the building now, the image of the building. Look at it here. We have it like this now. This is now. Are you getting now? 5 meters from the what? The pinhole. Now, then I said, if the image 2.5 meter is 2.5 meter high now, the height of the building now, the image here, they say from here to here like this, is 2.5 meters high. They say you should calculate the height of the building, which is the object height. Now in this case, we already know that magnification here, we know that is this over this equals to this over what? This. We have magnification as this. So in other words, our magnification here, our image distance is 5. We have it 5. Object distance here is what? We have object distance 300. Image height, we have it 2.5. Object height, we have it as this. So in other words, we can cross multiply here. This times this, we have this times 5 equals to 300 times 2.5. Divide both sides by 5. We now say 300 times 2.5 divided by what? 5. And that will be what? 150 meters high. That's the height of the building. The height of the building will become 1, which is exactly what is here. Option what? Option D. Now, here we have example 4 here. Now, this example 4 here, we are saying that a boy 1.200 meter tall. That is, this is a boy. Take this as a boy. 2 meter, 1.200 meter. This is 00 meter tall. This is the boy. You see now? Stand 3.6 meter in front of the pinhole camera. Meaning the distance the boy is standing from the pinhole camera is 3.600 meter. In front of what? A pinhole camera. Look at this. This is a pinhole. This is it. Stand in front of the pinhole camera. Look at the pinhole camera now. Look at it. Standing there. Now, along the line, pinhole camera, 3.600 meter in front of a pinhole camera. If his image is formed on the screen, this behind the pinhole, formed behind the pinhole, meaning the image here is formed, yes, 3.00 meter. This is what they're saying. Which is 30.00 meters. 30, not 3. 30.00 meters. You see now? Then I said, it said calculate the height of the image produced. That is to say, the image here now, we have to calculate the height of the image produced. So the height is from here now to here. We have to calculate the height of image. So calculating the height of the image here, we already know that magnification is what? Is this. This is the formula for magnification. In other words, therefore, we can say that image distance is 30. Object distance is 3.6. 3.6. Now, image height is unknown. Object height is 1.2. So in other words, we now say therefore, this become what? 1.2 times 30 divided by what? 3.6. We have it like this. Now, this times this divided by this, everything give you 10 what? 10.00 meter. So if you look at it in the option there, the correct option here is what? Is A. So next, in our next class, we'll be treating reflection at a plane surface. We'll be looking at reflection at a plane surface, just like that. See you. Try, click on that button. If you like the program, as we are running it, we are trying to help you out for your exams. So what you do, when you get there, you click on the button. Just try to what?